Okay, session 15, the penultimate session of the course. So well done for getting to this point, guys. Two more to go. We're carrying on with straight line graphs again. Well, this session, looking at parallel and perpendicular. Get a monster topic next year. So just getting ahead of speed to help you. And let's get straight in with a few examples. Okay, so in general, lines are parallel when they have the same gradient. Okay, that is by definition, lines are parallel when they have the same gradient. For perpendicular lines, when you multiply the two gradients together, they equal -1. So e.g., to use an example here, so if you had one line that has a gradient, so line 1 gradient 2 and line 2 half. If I multiply those two together, I get -1. So that means they are perpendicular. Okay. So if you multiply two lines together, it's also the negative reciprocal. So e.g. 1, I've got y equals, find the equation, let's say, find the equation of the line parallel y equals 4, passing through 4, 9. Okay, the point 4. So again, pause the video, have a go at this one if you think you can do it. I'm going to go straight in. Now I know that they're parallel, so it must have the same gradient. What's going to be different is the y-intercept. I know it's got to be y equals 2. And then I just substitute my coordinate in. I know y is 9, x is 4. So I just get 9 equals 8 plus c. C is going to equal 1. Got my answer there straight away. Y equals 2 plus 1. That's going to be parallel to y equals 2x plus 4, and it also passes through 0.49. Right, let's look at EG2, slightly harder. So we've got the 2 points. A is 0, 5, and B 1. Find equation of the line perpendicular AB and passing through the midpoint of AB. Okay, so find the equation of the line that's perpendicular to AB and it also passes through the midpoint. So a few things I'm going to do. I'm going to find the midpoint first. It's going to be useful. So the midpoint, to do that, I add the x's, divide by 2, add the y's, divide by 2, and my midpoint is going to be 9 over 2. I'm going to leave it in fraction. This is going to be 2. 9 over 2, 2. Okay. I'm then going to find the gradient of A. Do that. Remember, that's y1. I'll find the order that's going to help me best. I'm going to do 5 minus 5 minus 0. It's 9. So I end up with 6, negative 9. If I simplify that, negative 2/3. Okay. Now, if the gradient of AB is negative 2/3, the perpendicular gradient is the negative reciprocal. So it will be, flip the fraction and flip the signs, 3 over 2. So therefore, I know that the equation of the line is going to be y equals 3 over 2x C. Let's substitute our values. 2 equals 3 over 2, 9 over C. If we multiply that out a little bit, I get 2 equals 4 C. Little tip here, if you times everything by 4, you get 8 equals 4C. And then minus 27 from both sides. Get minus 15. Right? Double check. Yeah, minus 19. I can divide both sides by 4. Minus 4. So my final answer is going to equal y equals 3 over plus 94. And sometimes we don't like fractions, so I could, if I wanted to at this point, times everything by 4. Get 4y. If I times that by 4, that's 6. And again, often they want it in a form that's equal to 0, so it could be plus 90. Okay. So just take your time to follow that example slowly. Very, very important example. That sort of question could come up in actual exam papers. Pretty effective. That's it for the examples on this session. Again, you've now got the worksheet to complete with all the questions, including the extend. Okay, there's some quite challenging ones, but just do the best you can. All right, and tune in for the last session coming up shortly.